A particle A of mass m kilograms rests on a smooth horizontal table. It is connected by a light inextensible string that passes over a light smooth fixed pulley to a second particle B of mass 2 kilograms, which hangs freely under gravity. The system starts with from rest with A at distance 1 meter from the pulley. Okay. 1997, right? Okay. Horizontal table. Pulley. Or sorry, mass. Pulley. Okay. Then we have our string coming down and around. We'll do that. And we're hanging off the edge of the table. Okay. 1997, okay. So, what we have is reaction force R. mg going down. We have tension in the string. Tension going upwards. 2g going downwards. And we have an acceleration A. Everybody right with that? Now, any friction? No friction. Okay. So calculate the acceleration of A. So they have a common acceleration. Why do they both have the same acceleration? Connected by one string. Okay. So we're going to do is this. We're going to do for the mass A. Okay. What we're going to do is force. Its whole propulsion comes from the tension, which means ma equals T. Then we have the 2 kilogram mass, which ends up to be force going downwards equals weight going downwards minus tension going upwards. Its force is 2 times acceleration, which equals 2g minus t. We'll solve what acceleration is. So if I add both these formulas together, I'm going to add downwards. The t's will cancel and I get ma plus 2a equals 2g. A into m plus 2 equals 2g. A ends up to be 2g over 2 plus m. Everybody right with that? Okay, second part of the question. If A reaches the pulley in 5 hours 7 seconds, find m. Have to find the mass, okay? Now, how far away are we from the pulley? We're 1 meter away from the pulley. What type of question is this? It's a UVAS question. You start off at 0. Your final velocity, it hits it at speed, so although you get stopped, your final velocity is not 0 because you hit it at pace, okay? Then acceleration, we don't really know. We'll just call it A, even though we have an expression for acceleration below. What's S? 1 meter. T? 5/7. What formula should I use? Anybody? Sorry, I still haven't heard a suggestion yet. What formula should I use given this set of data? Ut plus a half at squared sounds pretty good. S equals ut plus a half at squared. Number 1 equals 0 plus a half a times t squared, which is 5 over 7 squared. Okay. Multiply both sides by, that's going to be 25 over 49, yeah? Half of that again will be 25 over 98a equals 1. A equals 98 over 25. However, A is also equal to 2G over 2 plus M. I'd like to change the 2G into 19.6. Okay, so we're going to cross multiply. We're going to get 2 plus M ends up to be 19.6 times 25 all over 98. 5 equals 2 plus M. M equals 3. M is 3 kilograms. Now, the diagram shows a light inextensible string having one end fixed at O, passing under a smooth movable pulley C of mass km. So that's k mg going downwards. Particle E is of mkg, or mg going downwards. Now, showing separate diagrams the forces acting on each mass in the system released from rest. So here's what you gotta do. You gotta do a graph for E. Now the tension, that's gonna be, is the tension the same all the way through? What? One string, one tension. T, T, T. Now the thing what you have to remember is it's not a common acceleration. Okay? It's not a common acceleration because it's basically, if you think of it this way, if I gave up, as an example, if I gave up 4 meters of string, let's imagine I gave up 4 meters of string. How far would particle E move? 4 meters. Particle E would move 4 meters. However, particle C would, although using 4 meters of string, it'll only rise up or down by 2. What does that mean about the acceleration of particle C compared to the acceleration of particle E? Half it. And look, we don't like fractions. I hate fractions. So let's call this one 2A. I'm going to say that one's going down, and this one's going to be A going up. You can do it the opposite way around, though, can't you? You can say that particle C is going down and particle E is going upwards. All that will happen is you'll have a negative answer where I have a positive answer. It will automatically correct itself to the correct direction. Is that alright? Set up your system. So we're going to draw the diagrams out separately. Not using that, we're not. So particle E, guys, what's going up and what's going down? Mg going downwards and T going upwards. That's particle E. Okay. What about particle C? Oh, and I'm saying A going down, 2A going downwards, and this one, KMG, T, T, and then A goes up there, right? Are we happy with that? And that's our system. Now, what do we do next? Show that the upward acceleration of C, it tells us it's upward, that's handy, is 2 minus kg all over 4 plus k. So we have to find that out. Okay, let's make a couple of equations. So just shrink these up. Put them over here. Nice. Okay. Now, what we get here is this, guys. We're going to get particle E. Particle E is of mass, so force going downwards equals weight minus tension. WTF system, okay? Now, what we're going to get is force is M times 2A. Its weight is mg, its tension is T. Then we're going to get 2ma equals mg minus T. We're then going to work on pulley C. So what about pulley C, guys? Anybody pulley C? What's the formula for pulley C? It's going upwards. Who's winning, tension or weight, if you're going upwards? Tension minus weight going downwards. So force is KMA, excuse me. KMA, tension going upwards is how much? And weight going downwards? KMG. Okay. I'm going to multiply the top equation by 2. I'm going to multiply this equation here by 2. I'm going to get 4MA equals 2mg minus 2t. They can cancel. And what are we left with? K plus 4MA equals okay. Now the m's cancel. Now guys, what we have here is this. We're going to have A is going to equal 2 minus K all over K plus 4. Is everybody right with that? Now, done. The G, did I leave out a G somewhere? Oh, there's a G there. Okay, next part. If K equals 0.5, find the tension in the string. That's handy enough. If K is 0.5, then it's going to be 2 minus 0.5 times G all over 0.5 plus 4. That's 1.5 G over 4.5, which makes the acceleration G over 3. The tension, which is located here, is equal to bring the 2MA this side, bring the T that side, equals mg plus 2MA. And then T will equal, what's mg, guys? Huh? Yes. That's G over 3. Okay, mg minus 2mg over 3. That results as 1 minus 2/3, which is mg all over 3.